In this section, we're going to talk about this wonderful figure called Wigger's diagram that connects all of the things that we've talked about with the cardiac cycle. So this is Wigger's diagram. I am going to tell you that you will be responsible for understanding this diagram, knowing what the lines mean, knowing when things happen, and being able to label some of the events that are taking place as we look at this diagram. So again, you can see we've got the events that we're connecting. So we're looking at the cardiac cycle and the different stages of the cardiac cycle. We're looking at the ECG and how that relates to these phases of the cardiac cycle. We're looking at the heart sounds, S1 and S2, where those occur. Pressure changes. We're going to talk a lot about this graph. So again, we looked before at the pressure in the left ventricle and the pressure in the aorta, but we've also added the atrial pressures here. And then we also are going to look at these changes in volume of the ventricle. So this is ventricular volume in milliliters. So again, we can see our maximum and our minimum and the changes that occur. So we're going to connect all of these. All right, so if we start at the beginning and kind of go back to what we talked about with the cardiac cycle, during the ventricular filling phase, what we see happening is that the pressure in the atria is higher than the pressure in the ventricles. Atrial pressure higher than ventricular pressure. So that is going to allow blood to move from high pressure in the atrium toward the ventricle where the pressure is lower. So we're going to see that ventricular volume increasing as blood is draining from the atria into the ventricles. There's no heart sounds. The aortic pressure, we're not going to talk as much about what's happening with that here. It's decreasing slightly because blood is continuing to flow through the systemic circuit. But if we look at the ECG, this is when the SA node is going to fire an action potential. And that action potential is going to spread throughout the atria and eventually get to the AB node. So again, during the end of this ventricular filling, we're going to see the atria contract. This is where that atrial pressure is going to increase, right? So right here is where the atria are contracting, and that's taking place right after that P wave. So the P wave's the depolarization, the atria contract right after that. If we then look at the contraction, and the first part of that contraction is the isovolumetric contraction. So during the isovolumetric contraction, this is the time when the ventricles have depolarized. So we're right after, so this is the beginning of the QRS complex, or right after that in this isovolumetric contraction stage. And that depolarization is spreading through the AB node, or has spread to the ventricles and caused the ventricles to contract. The ventricular pressure, highlighted in yellow here, is really what we're watching, because this ventricular pressure is rising, and it's going to rise until it reaches the exact same pressure as the aorta. That's going to end our isovolumetric part of this process. You can see that at this point right here, the pressure in the ventricle is going to rise above the pressure in the atrium. So the green line is ventricular pressure and the blue is atrial. So once the ventricular pressure rises above atrial pressure, that right there, that crossing of the blue and green lines, is where the mitral valve closes. Okay? So that is where we hear the first heart sound, is when the pressure in the ventricle increases above the pressure in the atrium, and we hear that first sound. Now this is isovolumetric contraction, so if we look at the volume of the ventricle, there's nothing changing. There's no change in the volume because our pressure in the ventricle is still lower than the pressure in the aorta, so no blood is going to flow into the aorta during that period of time. So then we move to the ventricular ejection phase, where the ventricle is contracting, and we actually are going to see blood leaving the ventricle. Okay, so at this point, when we cross the aortic pressure, so the pressure in the ventricle, the green line, exceeds the pressure in the aorta, that purple line, now we have blood moving from high pressure in the ventricle to lower pressure in the aorta. So blood is going to leave the ventricle. So that blood is ejected, so the volume of the ventricle is going to decrease. Okay? So this is the point where we are seeing blood moving into the great vessels. And if we then move to the next, our isovolumetric relaxation, once we reach the end of that contraction cycle of those contractile cells of the ventricles, the pressure in the ventricles starts to drop. As the pressure in the ventricles drops below the pressure in the aorta, then we see the aortic valve closing. So that's where we get our second heart sound, closing of the aortic semilunar valve. That pressure is going to drop, but the pressure in the ventricle at this point is still higher than the pressure in the atrium. So we're not going to add any more blood to the ventricles. That volume is going to stay the same. That's the isovolumetric part of that relaxation, that decrease in tension that causes a decrease in pressure, but we're not going to see any more ventricular filling again until we get to the point where the pressure in the ventricle is less than the pressure in the atrium. That will open that mitral valve again. Okay, so that was kind of a quick overview of the Wiggers diagram. Again, it's something that we'll work on in lab as well, so you'll be very familiar with that. Again, I think I'll stop here and kind of keep this section short and do one more section at least that talks about cardiac output.